Okay, it looks like we're live. So welcome back. Today I'm going to be well, I'm gonna be working on Kano script, but I'm gonna do something a bit different. So it's sort of not really a new project. It's sort of a sub project of both Kano script and the virtual machine. So if you don't know, I made a virtual machine some time ago, and I expanded upon it a bit recently. And then I've been working on building a scripting language which compiles to the bytecode of that virtual machine. And so now what I want to do is sort of extend the virtual machine to include a debugger, right? So we have GDB, and that's a debugger that we can use right, and we can use it on like C programs and things like that. But I would like one that would work for the bytecode of Kano script, of the bytecode for my language. Now I'm gonna start out where it's just gonna be assembly, right? You go through it's a special representation of assembly. It's not like x86 assembly. But it's gonna be a certain kind of assembly that you can go through and see. And in the future, I'll expand it so that you actually see like the programming, like the language, right? Like how you would with GDB using C or something like that, right? But that's sort of the idea. So I'm just gonna make a maybe this one. Yeah, I can delete all this. I'm just gonna make a test project that I'll compile and then I will use the debugger to sort of run through it. Yeah, I'm just doing this because it's gonna be pretty fun, I think, and it'll be useful, I think, to go through it. Because right now I have something that can disassemble it, so we can disassemble it and look at what the assembly would look like. But it'd be nice to be able to step through and view values and things like that. So that is the plan. That is the plan. Yeah, streams are going good, so that's good. So let's just make well that, and then x equals x plus 1, right? And then x over that. So we'll just do this, right? So a few things going on here. This will call a function that we won't really see. So it's really just going to be exiting. So what I'd like to be able to do, actually, let's see what this compiles into. So if I run compile, there's a null byte at the end. I need to fix that. There's some issues with Kano, but that's fine. Okay, so it compiles, so now we have Kano.tim. So if I run it, actually I'm not sure if it's gonna work because I don't know that I have it. What is this? Right, so I want to look at this, and then I want to go to the build, and then, so I'm not sure if it's up to date enough to actually work, so I'm gonna try it though. Disassemble, and I want you to disassemble this one. Right, so this is, assuming it's all working, this is what that would look like. So native one, that would be calling exit, right? That is the syscall. This duplication is grabbing the variable value. Yeah, so that looks like it's probably about right. This is the value that we push. This is the, actually I'm not sure what that is necessarily. But right, so we'd be able to step through and see this. That is sort of the plan. So it's not going to be too difficult. It should be fairly simple to do the assembly. It'll be a bit more complex, if we want to be able to see the Kano script code, because we'll have to save all the symbols and things like that. But with this, we'll be able to look at least this, right? So that's the plan. And we do have access to the data types at runtime, so we'll be able to display it properly. So it's in here. It's all in one single header file. It's actually not too big considering what it is. But I have this this is the one function. Right, this is sort of the main run function. It's just a big switch statement, basically. There's probably some stuff that could be cleaned up in here as well in general, but oh, that's the disassemble. No, this is the disassemble. Okay, right here. So it's gonna be. We'll start with that as sort of a placeholder. So I'll put it here. I'll make machine debug, right? Debug. And yeah, we just need the machine. We'll iterate over it. And yeah, so for now, it's just gonna look the same as the debug. So to run this, actually, right, I'll need to add another flag, and I'll do that. Let's see up here. Yeah, I need to add this to the header part of the file. There we go. So if I do that, and then I'm going to open a new one, and I'll go to the main.c file, and where we have this, yeah, we have that, and then else if, I could use something different for the flags as well, so I have that, but, so this will be bb, right, so it's not going to be a separate tool, it's going to be actually integrated into the thing, the program. Then what we want to do is set compile false, set the file name, right, and maybe the flag should be different. This is run instructions, right? So that's if we're compiling it, But what I want to do here, so I still want to do all this. Hey Stan, how you doing? What is up? HI, hi. So let's actually let's make compile. I'm gonna you know, and then it'll be 0, right? So compile equals 1 if we're compiling it, and it'll equal 0 if we're doing that, and it'll equal 2, right? So I'm just gonna do it this way. I can clean it up later, or whatever. Learning AST parsing, nice, nice. It's kind of hard to wrap your head around, but once you get it, it's pretty useful. This could be a source name as well, but yeah. File equals 0, and then else we'll just want to actually want to debug it. So let's do program, not yeah, machine debug rather. Debug machine, and I think everything to be cleaned up is going to be the same. So let me try that. Can I build it? And I did that wrong. So yes, it's 2. There we go. Alright, it built. Going crazy. Is it hard or what? Why are you going crazy back? Let's do DB. And yeah, okay, so that works the same as that. So that's actually useful to have in the first place. So I should probably add that as like yeah, but I'll worry about that later. So what I'd like to do is I want to print it out and then scan the input. So you can, for now, just have next, right? That'll be the command. So I have next, and you press enter, you know, reads the input. It prints out the current line. So it's not going to be a nice, nice GUI kind of thing. You know, like we have this. It's not going to look quite like this. In the future, I would like that, though. Or not really a GUI, but a TUI, right? A TUI, whatever. Whatever you call it. So, yeah, that's in here. Machine debug. Let's go here, and so I still want to print it out, but then I want to wait. I want to pause while we read the thing, right? So let's make this actually, let's change the condition, right? Well, do I want to change that? I want to actually change this, so I don't want to iterate it every time. I want to iterate it when we press next, right? So now this is just going to loop for forever, basically. But I want to print it out, and then we print all this stuff as well, that's fine, but then print the new line, and then I want to scan F, so let me look at scan F. Scan F, right, so we scan it like that, and we should be able to scan sort of the input into a string variable, I think. I'm not using scan F very much, but it should be something like this. So, actually, print F first, so print F, or do something like that, I think would be acceptable, and then we can do another one for the This could even be with char that we figured out. Right. And I'll make it, you know, a 2-8, maybe use end curses or something like that. Perhaps. I might not do that. We'll see. Yeah, this could be... Actually, let's just put C, right? Right. More efficient, I'm saying. So scan F into, so this will be the command, basically. Let's make a command, and, you know, we'll just make it like that, I think. And we'll scan F into it, right. And then I just want to see what it is. So if command, I'll use this for now. Command is n, right? So we'll be able to read more characters in the future, so that's why I'm gonna do it like this. More than just one. But if that is the case, I'm gonna do I plus plus. Otherwise, we'll just continue. So let me try that. Let me make sure it's all builds. Yes, here's some issues. Yeah, these are supposed to be a character. Okay. Let's try to run that. Not GDB. Yeah. Push 12 next. Otherwise, yeah, we won't actually print it again when we press enter, or when we, you know, just press enter. But yes, that is sort of how I want it. So we're stepping through the program, you know, and we can't really see see the value of anything or anything like that, right? So we want to see the value of the stack, pretty much is the thing that we want to look at. But that's, you know, that's pretty close already. If that else, I guess we'll just put this in. No, that's not right. No. So that doesn't quite work. Let me put C as well. Let's see. So what is this? Mm, closing for that. So this is still in a loop. But it doesn't seem to work. Let me see. Maybe I wanna. Well, I don't want to bring this till after that. Oh yeah, I forgot the standard app for this one. Why does it not work exactly? So if it is that, otherwise we just put this. It doesn't work. And then it also it does this again, but it doesn't do that. Mm, doesn't print this again. And then let's make this a wall. Wall. This. You know what? It's probably to do with how scanf works. That's what it is. Right. We have to, yeah. It could be not reading that. Well, it should, I think. Even in theory. And I'm not super familiar with it. So, yeah, it seems to not. So that is an issue. So it should read that. Let me see. Maybe I should do app-gets. Let me look at app-gets. Gets. Stream. So like stream would be standard in. Right. So what are the arguments? Char. Wait, what is S? Oh, it stores them into that file. Okay. Like that, and then, like that. Right. Okay, so that is more how I wanted that to work. Let's get rid of this quickly, because I don't know that I need that. Okay. Yeah, so it prints it out every time. I don't necessarily want that. Right, because I'd rather, oh, and also next doesn't work anymore. What? Oh, shoot. Yeah. Hello, Stam. How you doing? Mm, very good. Glad to hear it. For sure. That works. It's right. We could have other commands, but I suppose, let's see. Yeah, so I don't want to print everything out each time. So I want to, this could be like print line, you know, that kind of thing. So afterwards. And then, I suppose here. Right, so then it's more organized, how it sort of bunch together, right? But once you do this and then print this. I want to do it like that. Maybe not. I'll try that. And since this stuff is the same as in the debug one, that can be its own function. That will call, so we'll get there. Let's make, equals false. And then we'll set printed equals true. And then printed equals false here. Then it'll just, won't print the extra stuff. Yeah, there is some extra new lines as well. There's, well, that shouldn't put a new one. I need this though. But there's a new line after reading it, right? So we do need that. Okay, yes, that's what it is. So we don't need this. We do need that. Nope, I got rid of the wrong thing. Hang on. We don't need this. There's still an extra new line. So what is that from? Let's put a new line up here. Doesn't look like it does. Hey yo, sus. How you doing, Cactus? What's up? Mr. President came here to say hi. Hello. Mr. President doing good. Glad to hear it. Glad to hear it. Why does it print something here? Where is that from? So when we press that, it doesn't print here. Oh shoot, but it does this each time. So what we want to do is actually put this at the end here. There we go. Okay, yes. That makes sense. Watch the next stream. I'm busy with Minecraft. Okay, all good. Almost finished and can't wait for it to be done. Hope you have a great one. Well, you as well. I'm glad to hear it's almost finished as well. I cannot wait to play it. There we go. That is what I wanted. And then next goes to the next one. Okay, so that's pretty cool. That's pretty cool. So that's already something, right? What else at the end? It just ends, right? What the heck? Annie's node? What? 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 Yeah, so it does just say, node? I did not know N was that hand. Well, it's not in there. That's kind of sucks. Wait, what the heck? It's not even regular. How do you exit? Exit, leave. Oh. Kano was a Node.js forever? It's over. It's over. Exposed. Wait, what is this though? Oh, it's updating it? What the heck? Okay, I didn't know that was a thing, so okay. Yeah. So for this next part, I need to do it a bit different, right? Because what we'll have is, let's say we want to print, right? Print the stack. So print stack, and then you'll put the number of elements. So it's going to be like a small amount of parsing. I'm not going to do it in a very very complex way, right? So you could do 1. You want to print first element, or 10, or 25, or whatever, you know, something like that. To sort of display them, and then we'll print them out. I guess new line separately. And there will be a few different keywords that you can use. So you can print. Well, I guess for now there won't be anything other than stack. So maybe I can just do P, right? And then I just have the next word. So I might do that. Maybe. Fgets, does that return? It's not return that. Okay. If let's do this. So that equals no. Could not read string. Right. Okay. I think that's what it's called. Why is unreachable spelled that way? Where? Because I was holding down shift. There we go. Is that better? Holding down shift and then let go for a few characters. It shouldn't ever get to that point, so that's why I don't really care what the message says. Just fix a major about real. Okay, so do that, and then we want display. So it's actually this first command. It's only going to be one character. So what if we read one? You know, just could be a switch command. It's always going to be one. So this could, yeah, we don't need this to be an array now. It can just be a character, but we do need it to be a. We do need it to be an array because of that. But okay. So we know that it's not no at this point. So if command equals n, then we'll do that. So that's for next, right? We'll switch over. Switch. Indentation's all messed up. Case n and case p. So we'll have n and p. But this okay. And here. So this I'm just gonna think that. Right. For now, it's just gonna be the stack. So the next part will be how many characters. That sort of thing. Let me try that. Okay, that did not work. Why did it do that? Can you not read one? Okay, I guess that was what it was. That. Oh shoot, but it prints it now twice. That is interesting. Why does it print out twice when we have one of those? I don't know why. Sus. Well, yeah, okay, this could be Fgets actually. That makes more sense. Yeah. Then I would just return something. So let's do. What does it return? Equals. We'll just get C. Yeah, standard in. Okay. And if command equals end of file. That's an program. Yeah, no, not do this. Okay. I'm gonna have to dereference it. Yeah, why does it print it twice though? Why does it do that? shouldn't be any different, but what does it when we read one? So somewhere it's printing it twice. Right here, do that. Print it equals false, and then we go back up here and we print this out again. And we print a new line, then we print this. But why does it do it twice? So do it get C. I don't know why it would do that exactly. Printed. Well, no. Okay. What causes that though? We increment this. We say it's not printed. Why does it do this twice? What are you working on? I am working on a debugger for well, it's actually two projects that are sort of intertwined with each other. So I have one here, right? So this is this at one is a virtual machine that I made, which has like a bytecode and things like that. And this is a scripting language which compiles into the bytecode. And so what I'm working on is basically something that will allow me to debug the bytecode of it. So it looks kind of like this. It's a little, I just started working on it, but so it'll go line by line. It's the assembly representation of the bytecode basically is what it is at the moment. So we can see what the current the current thing being executed is, right? And we can continue through and see all of them and things like that. Yeah, that's basically what I'm working on, is a debugger. But yeah, it's a bit primitive at the moment. Nice, yes. Let's head out here and read this and go to the next one, print more stuff out, but then it does it twice. That's something to do with what it's reading, I think. I'll just continue on for now. Right, I guess now I would want to read again, but using fgets instead. Fgets. So let's do so this is like the size, right? So this will be it's gonna be an integer once we read it. So we need size. Does that let's not go first, right? I was using it. Okay. Wait, it does go first. All right, and then 128, and then what was that? Oh yeah, read that, and then also you can check to make sure it's not null. And same thing, right? Same error. And then we can convert it to an integer. So int size could be a size. So equals. Well, yeah, I just need that. Integer. So it could be negative though, so we don't really want that. What is it for that? Not one of those. So maybe maybe I'll check to make sure. It's not going to be too large a size because it can only output so much. But then we need to iterate over it and print the topmost elements on the stack. So so I want to start at the chain stack size. And then while well, hang on. No. So we'll start actually at that size. While it is greater than 0, subtract it. And then I just want to print the stack from there. So we can do print out. So this will be well, the stack element. It could be something here. So we need to really print this. Not necessarily the instructions. No, so it's not quite that. We do have stack. Something like this. So this iterates over the whole thing, but I think it's one. But not exactly. I need to switch over the type of it. We'll do that after, I suppose. Right. Yeah, so we'll switch over the type so we don't print out all the information, but which actually I guess that is similar to what we do here, isn't it? Because we switch over the data type and we print it out depending on that, and we could just do that for the stack. So this could be a function, perhaps, right? Because all of them use the, well, they use the string. Maybe. It depends, but we'll see. If it's a string, though, well, we'll see. And then we want to do that a bit differently, though. So machine stack, it's not I, but instead equals machine stack size minus I. Well, hang on. So we want to start at 0 then. Size greater than stack size. If it's greater than that, it could be equal to it though. Then we want to print an error. Right, so, well, error. Maybe don't want to necessarily crash, but I'll do that for now. And print that element that stack only has that stack size. Okay. Yeah, so like that. Starting at 0 while it is less than size. Okay. It's current here. Alright, some issue. So this is stack size not right. Wait, what? Stack dot count. Oh no, it's stack size actually. Size like that. Okay. Okay. I did that the wrong way. Stack size. Yeah, so same thing. Okay. Wait, what? That is an integer. Oh, shoot. Why is it an integer? That's kind of weird. That's kind of clear. Where is that? Oh, yeah. Okay, there we go. And then we can run it on here. And print 10. Okay, it's stacking at 0. So we'll wait. So now we have 1. Stack, why does it have 0? Oh, shoot, because we're not actually executing it, right? So we need to do that. Something we need actually is run instruction, right? Where we pass a single instruction. So let me make that run instruction, and we just pass the instructions data IP. That's the current instruction, right? And then all of this goes in there. Right, there's a lot of stuff here, so yeah. Let's see. I do need to make some functions and stuff, but break, yes, it's right there. Shoot, and also we need the machine, I guess. Yeah, let me copy this again because I messed it up. It's gonna take a second. Holy case, yes. Like I said, I did write this quite a while ago, so yeah. Most of it is like this kind of stuff though. There's like 70 instructions or something like that, so what the heck? Why did it do that? Fix this. I don't know what that means. Why is this one indented different? Okay, well that's let me see. Delete that. It's a little slow. There is a newer version that is faster, but there is some bugs, so I cannot update it again. And then we can actually define this up here. That's somewhere. So, why is it indented differently? I need to fix the indentation. What the heck? How did this even happen? Also, why is there more than one? Oh, shoot, no, that's like, okay. That's not very good. I might need to actually remove it all and copy and paste it differently. I don't know why it did that, though. Why it would do that. It's fine for now, because I'm not reading it, but go to that to initialize them. Well, they're uninitialized, but let's do that and pass the machine. Right. With that work. Almost. Instruction, and I want to change this. So can I just do that? Continue. Oh shoot, it's not in a loop. So we can just return there. We do need IP as well, though. Hold on, it's just break, yeah. And we need this as well. Find up here. Oops. IP is not known. What? Why? Oh, I forgot. There we go. Okay. Like that, and it does work, yes. Alright, so now we want to run each individual instruction as we go through, basically. And I is the IP, right? So let's let's print it out and then execute the instruction. And we want machine instructions. Data I. Also machine. And just I. So once you execute it, so that we actually build up the stack and things like that. Okay, and there we go. So that is, why is that the top of the stack? Is that iterating it? Oh shoot, you can't use I in here. That doesn't work. Yeah. Okay, so that messed up. Let's try that again. So we'll print why is it like that though? So stack size is 3. Why does it have 7? I don't think that's quite right. There shouldn't be that many at the start. Running a single instruction increased it by that many. I feel like there is garbage data of some. I don't know why though. Actually run the instruction first. Whoops, something lag. Well, we don't want to run it each time. Yeah, okay, that might be the issue actually. Yeah, because we ran it each time we did it. Okay, that is better. So print 1. Why is the topmost one that though? Why is that the top element? I don't. We printed out wrong here, perhaps. Whoops. The current stack size. Oh shoot, but we need to do minus 1 more, right? The stack is pointing 1 above. There we go. Okay. So that is the current stack size, right? And then that is the one below it. There we go. So yeah, that subtracted 1 from 1. So we have that, and then, okay. I also like a stack size command to just see what the current stack size is. That would be useful. So we duplicate it, so we get another 12, and then we have a 1. We have a 1, 12, yeah, so 1 and 2 12s, basically. Again, I don't want to print it all out at the same time. We'll get to that. Add them together, stack size 2, push 1, subtract, swap. So we swap with 12, we pop off the 12, push a 1, subtract. And then we segfold. So that is interesting. Indupe segfold. Why did it do that? Yeah, why does it do that here? Oh, shoot, wait, that's not the last command, though. So that one's fine, but then we go to the next one, and it's segfolds. So the one after indupe, index dupe. Oh, shoot, I know why. So we need to, hello again, Stam, how you doing? We need to load it properly, because we do not do that. Right, is that what it is? Very good, glad to hear it. Right, we have exit, native exit, right? Where do we load that? Yeah. That's in the run instruction. So we want this, we need to do this as well. Right, that needs to be loaded, so that is the issue. This is the single run instruction, which does not look very good, but parser for shard. Okay, okay. in a VC right now, you'll die by the end. Huh. Hopefully not. Mm-hmm. Yeah, this needs to go to the start. We need to load those. That is very important. Gotta do that. That is why it said false, right? Because we do not load that. We don't have the exit assist problem. Undo. And there we go. It exited. So we didn't see the last one, so that is not good. Oh, because it exits. That's why. Yeah. So we want to run the instruction after. That's right. But we still want to do this. So like that, and then we'll be able to see it at the end, but it will exit. Oh well, maybe we want to. We don't want to print it. We don't want to execute it until we actually run it. We probably want to do that actually. Now that I'm thinking about it. If they're gonna exit the same, but it's gonna print it out as well. Native, yeah. So native, it doesn't show the operand, so we do need to print that as well. That's probably a good idea. But yeah, so we might want to do this at the end, where we do like this. Once we press next, then we execute. So then, right, if I run it, I print one, there's nothing on the stack. Right? If I go to the next one and then print, then it does. So that's going to be better. So we can keep going again. Native, right? And we can print all that. There's not 10, but right. So then that way it doesn't actually execute until you press next. So that's better. That is a better thing. So we can get rid of this printed here. Reads that and it prints out that. So we can switch over the type and things like that. I want to. Why doesn't it print out the operand? It should. Oh shoot, because native does it by the stack. That's why. So that's why there is no operand. That makes sense. Yeah, but if we run that again, we print the top one. If we get it in. Yeah, print the top one. That's not right. It's not printing the whole thing. Yeah, that needs to be like this. Hello, Stan. How you doing? Let's try that. Okay, and then that. Okay. Next. Right. So it doesn't print it properly. I think it has something to do with the pointer. So that's fine. I mean, fine. What about you? I'm good. I'm good. How's the parsing going? This basically can be what we use. Yeah, so again, I can make a function for this or whatever, but not yet. Right, and then I just want to switch over the operand, basically. Machine stack. Making pseudocode right now. Recursive descent parsing. Yeah. Yes, indeed. So, I don't know necessarily that's the exact. Let me look. Hang on. I have the. Give me a second. Give me a second. I have to find the thing I was using. Let me see if I can find it. Because there was a particular Wikipedia page, right? It might take me a second. Is this the one I was using? Would have been this. I'm looking on the second monitor. It's gonna take a second. Your scheduled video got dropped finally. Oh, okay, I've not seen it yet. I will watch it. Dang, I cannot find it. Oh, okay, I was using, yeah, operator precedence parsing. Right, so that's that. Okay, I guess it is something different. So I haven't used recursive descent. I don't remember exactly how it all works. Yeah, so I haven't really used that particular method before. The rock, ayo. Stack. I feel like we could use value here. So if we do is it data or is it a word? Stack current. We use value. Well, we can't call it value. We'll call it the element. We could use element. See, I think it's a word actually. Very enjoyable programming, real. Oh, that's the wrong thing, so that can stay like that. Right here, I want to use element. But element doesn't have the data type, does it? Or word does not. So that doesn't, it is not that. Okay, so it actually is a bit different. Yes, this isn't gonna work. Even if it was, well, let me leave that. Top word. Yeah, so we need to interpret it like this. So this dot value, it's not exactly what we want. So we want to do dot word instead. So this will be like that. Okay, there we go. That's what it is. That is what I want. It sees element dot type. And then dot value here is word. Word. Almost typed uwu. Let's see. Do this. Might just be dot type though. We can get rid of this. It's just gonna tell us. Yeah, so it's dot type. Right, okay, so this we don't have. So this is different. Whoops, I did not mean to do that. So if it's a string, I don't know that we have a string type exactly. We won't necessarily know if it's a pointer or if it's a string or not. Data type. We don't really have that. So that's not something we can know exactly. Shout out to Anthony and Nick and all your friends from Shark W. I've not really contributed anything to it. I said I would, but also it's Rust, so you know. Let me try that. Main. Said I would, yes. Yeah, print one. 12. Yeah, that needs to print a new line as well, I think. Also, when I said that, there was no documentation or anything like that at all. Always trust whoever tells you to build config real. Yeah, I like to print the stack element, right? So print the index on the stack. Let's try it. So I want to use current or index. Oops, there is no quit. I need to add quit. Next 0. Alright, so that's at the bottom of the stack. Well, I'd like to see. Let's put index. Starts at 0. So minimal. Alright, I'll look at it now. I am subscribed, but I am in the private tab, so it's gonna be unsubscribed. Alright, nice. And it's gone. What the heck? I dragged it over and it's gone. I don't like browsers, you know? Hang on, give me a second. Okay. Can I just do that? There we go. Now I can see it. Yes. Nice logo, nice logo. Yeah, good logo. I like that. Let's see. This is the one that went off. I remember that. Yeah, I'll watch this afterward. Why incognito? So you don't see all the subscriptions over here. I have 2,000 of them or something like that. Yeah, I can't watch it now, but W. I like the logo. Actually, now I'm gonna mess up your watch time. My bad. I shouldn't have clicked on it. My bad. There we go. You got a few seconds. I'll go back and watch the whole thing a few times. I'll watch it a few times to get it back up. Bruh. Yes, very cool. Very cool. I like it. Very nice looking. I should make a new logo. Okay. Index. Vector. Index. Why? What? I don't want it. New thumbnail side. Yeah. Looks good. It looks good for sure. So 0 is like the top, but it's not exactly. Is that what I want? I suppose that works. Yeah, I'll stick with that for now. I just have something. And then print them all out. Put the new line as well. So yeah, we can see the stack and the elements and things like that. And then right, so that's already pretty useful. So I can exit. Work in progress. Debugger or right. So I'll merge it with the actual that's a lot of insertions. Okay, I'll merge it with the with Tim as well later. I don't want to do it now. A new PFP. We'll take a look at that. It's loading. Genius. Yes, perfect. Works so well. Okay. Path value, and yeah, we can know what it is. We just don't necessarily know if it's a string on the stack. That's the only thing. Yeah, I would like to figure this out. So when you type stuff that is not valid, what is that? I don't know why it does that though. But anyway, so we can add a Q command as well. So just exit out. Well, we'll return. Yeah, we still need to free all the stuff and everything. Next and quit. Yes. Okay, perfect. So that works. That works well. Just displays the stack. There's not really something else that we want to. Maybe we could put the type as well next to it. I think we have something to print out the type. So we'll print out the current type. Actually, let's put it up here. We'll put like type is that. And I'm not sure what it's called. It's something like that. Element dot type. So we'll move this down here. Right. I don't think that is what it's called here, but type. Do we have an array of the, data type? Maybe we don't have that. Just need to print what the type is. That would be good to have, but we don't seem to. Mm, okay, maybe I won't do that then. String types. Oh, yeah, okay, so we do have this. Oh. Okay. Try that again. It should be up to date. Maybe not. Yeah, but integers, so they all are going to be integers here. There's only two. Yeah, I need a stack size command. Well, it could just be S, right? To stick with that kind of thing. So this S, we'll just print out the current stack size. So we'll just S is that. Machine stack size. There we go, and that's it. That is all. S. Alright, stack size 1, stack size 2, stack size is 3 at that point, so we can print out 3, and yeah. Okay. Cool. I still need to fix this, but I'll worry about that later. I do have to go in a minute. But yes, that's cool. You can see the data types. Let's actually add another data type. So we'll do y equals 2.0. And we look at that. What's 2.0? Okay, print 1. And top. Okay, so that the data types are not quite right. I have not updated, I think is what it is. Top is like the top of the stack. I don't know what that's for though. Yeah, it is not that. So we have int u8, u16, u32, u64. Yeah, then we have the float and double. Also heard recruiters like when they see YouTube or Twitch channels. Do they? Perhaps. Some do. Some might not. Like older ones, maybe. Char, pointer, yeah, okay, so. Heard that from neat code. Neat code, cool, cool. There we go, now it is the right time. Making leak code videos. Yes, I am familiar. Okay, yeah, so it displays the proper types, and that's when you add, well, let's do a string, and let's see what that looks like, right? So it's not going to work properly. It's going to push it, but we're not going to be able to display it, right? Right, so we can see that, but we can't see, if we look at that, it's just a pointer. So we could do print string. Well, actually, I don't know that I could do that exactly, but, maybe. It'd be nice to know if it was string, but we don't really have a way to know that exactly. Yeah. Okay. Yeah, so I'll commit that, and then I do have to go. Printing better on debugger. Okay, that's gonna be super useful once it's done. Get add dot best command. Yeah, I think you're not supposed to use it because reasons or whatever, but I don't care. Add everything in case you forget something real. Yes, I forget everything. So, but yes, that's gonna be cool. So then I'll be able to debug, and that might be useful for the bug that I've been encountering to do with CanoScript, right? With calling separate things. So we won't be able to see the C code that we're calling in the debugger. But we'll get more of an idea of what it's doing while it's running, and we'll be able to see sort of that, what it looks like and stuff. It would be nice to have one that works with CanoScript, right? Where it's not the assembly. But that's going to be a bit more difficult. Unit test for real. Okay. Wait, one last thing. Okay. Token splitting? What do you mean? In CanoScript. Token splitting. I don't know what you mean by splitting. Characters into tokens. Oh, well, I have equal turns into token equals. Oh, okay, I see. So I have a few different ways that's handled. let's see. So we have this compares it with built-in stuff. Let me go down to the Lex function. That's where it's at, right? So we Lex. So we have like this. So if it's at this is like preprocessor stuff. So that is, oh, I have that. That's kind of, yeah. But then I have just a switch statement over the data, right? So if it starts with any of these, so if it is that, any of these, and then there's some other things here. So this will consume a string, right? This, yeah, this has to do with the string as well. New line, so that'll just go to the new line because it's reading that. Wait, why does it do that? Yeah, okay, that makes sense. And then here we check if it's alpha numeric character, right? Right. So this is if it's not any of those, then we'll go here, and this will actually go through the whole string, right? Probably could use some functions for this though that I actually have implemented. I just didn't have them at the time. Token preprocessing best real. Yeah, and then if it's a digit, we consume it in a similar way. This is for, yeah, this is for the base type because you can have different bases. And then what else? Is operator. So we have a function for that. So let's look at that. Is operator. Yes, that has a few different things. So this is what the operator is. So if it's any of these, it is an operator. If it's this, then we grab the next one and return true as well. And then also we have create operator token, which does a similar thing, but actually makes the token. Stolen from Sharp. Yeah, for sure. Yes, I stole it from Rust and then converted it from a Rust project and converted it into C. Yeah. So that's basically how it works. It's pretty simple, most of it. Can get kind of complex, and I could make it a lot better. Just looking at the things there. Like I mean, this is fine, I think, for the most part. Maybe some checks are needed, but yes. Shard code base cosplay like any other language. Yeah, for real. Yeah, that's pretty much all of it. We also have this for getting a string. I don't know what this is for. I think let's get it. Yeah, but that's pretty much all of it. I don't know why I have this because that should be handled by this function, but I guess it's not. C inspired by Sharp. Can confirm. Okay, yeah. So I will go now. What's that? Okay. Kano confirm. Real. Alright, yeah. So thank you guys for watching, and I'll see you next time.